That m is the mass of the rest part, that is this is the mass. Then m equals to will be m by pi r square into 3 by 4 pi r square, because area of rest part is 3 by 4 pi r square. So m equals to 4m by 3, and m dash will be equal to m by pi r square into m into r by 2 का whole square equals to m by 4. Now m dash mass of the part portion, then m by pi r square into pi r square by 4 m by 4. Now moment of inertia of cut portion and about new cm, io dash equals to under of bracket 1 by 2 mr square plus m into r by 6 का whole square minus under bracket m dash by 2 into r by 2 का whole square plus m dash into r by 2 plus r by 6 का whole square. Solving we get the result. A disc of radius r by 4 is cut from a disc of radius r and mass m. Find the moment of inertia of the rest part of the disc. Here xcm equals to m into 0 plus minus m by 16 to 3r by 4 divided by m minus m by 16 equals to m dash equal to m by pi r square into pi r by 4 का whole square m by 16, और solving we get minus r by 20. Moment of inertia of cut portion about new cm center of mass will be 1 by under bracket 1 by 2 mr square plus m into r by 20 का whole square minus of under bracket 1 by 2 m into r by 4 का whole square plus m into 3r by 4 plus r by 20 का whole square. In this case Ixx will be Icg plus m into r minus 4r by 3 pi का whole square, and so I0 equal to Icg plus m into 4r by 3 pi का whole square, Icg equal to mr square by 2 minus m into 3 pi का whole square. So Ixx equal to under of bracket mr square by 2 minus m into 4r by 3 pi का whole square plus m into r minus 4r by 3 pi to the whole square. For hollow sphere, elementary mass dm equal to m by 4 pi r square into 2 pi r into dx. Hence Icg equals to integration dIcg integration dm into r square m by 2r square into rq dx. Okay, m by 2r square minus r2 plus r. Now rq equals to r square minus r square minus x square to the power 3 by 2 into dx, or 2 by 5 mr square. In this case dm m by 4 pi r square by 2 into 2 pi r into dx. Hence Ix integration di integration dm into r square m by r square 0 to plus r rq dx, or m by r square 0 to plus r square minus x square to the power 3 by 2 into dx. For solid spheres, elementary mass dm m by 4 by 3 pi r cube into pi r square into dx. Okay, so integration di integration dm by 2 into r square, or 1 by 2 into 3m by 4 pi r cube into r to the power 4 dx, or 3m by 8 r cube minus r2 plus r under square of r square minus x square into dx, or 2 by 5 mr square. Here dm equal to m by 2 by 3 pi r cube into pi r square dx. So So I integration di dm 1 by 2 dm into r square 1 by 2 3m by 2 r cube into integration by r to the power 4 dx at 3m by 4 r cube 0 to plus r square minus x square the whole square dx. For solid cone, elementary mass m by 1 by 3 pi r square into L into pi r square into dx or 3m by r square L into r square dx. So I integration di equal to 1 by 2 dm into r square 1 by 2 0 to L 3m by r square into L r square dx into r square 3 by 10 m r square because r by L equals to r by x. So r equals to rx by L. In this case y cm equals to integration y dm integration y into m by root 3 by 4a square into 2x into dy divided by integration m by root 3 by 4a square into 2x dy integration xy dy beta integration x dy integration 0 to root 3 by 2a y square by root 3 dy by 0 to root 3 by 2a y by root 3 dy. Hence y cm to a by root 3. Now moment of inertia I have integration di have integration dm into x square by 12 plus dm into y square by dm into m by root 3 by 4a square into 2x dy limit 0 to root 3 by 2. Similarly we can find the moment of inertia of this different situation. Now angular momentum and torque or moment of force, angular momentum or torque or moment of force. It is also known as the moment of momentum and it is defined as the cross product of the position vector and the linear momentum. It is always defined about a certain frame of point. Mathematically we have L0 r cross p equal to r cross mv vector or L0 equal to m into r cross v. In magnitude L0 equal to L0 equal to mv into r sin theta. If r perpendicular to v from rotation L0 equal to mvr. Also we have L0 equal to mvr into sin theta or mv r sin theta. L0 equal to mv into perpendicular distance to v vector. In projection form we have L0 equal to r cross p m into xi equal to y j cap z k cap into vxi equal to vy j cap z cap. So m into under determinant I j k x y z vx vy z. Solving this we can get the value. For system of particles sigma L0 equals to L01 plus L02 plus S dash L0n equals to m1 into under bracket r1 cross v1 plus m2 into under bracket r2 cross v2 plus dash mn into under bracket rn cross vn equals to sigma I equals to 1 to n mi under cross ri cross vi. For rotational motion ri perpendicular to vi and vi equal to omega ri, sigma L0 equals to omega into sigma I equals to n mi ri square or sigma L0 equal to I omega and sigma L0 equal to I omega vector. Moment of force or torque, it is defined as the rate of change of angular momentum or tau O equal to delta L0 by delta t. When delta t tends to 0, torque about O, that is tau O vector equal to d by dt L0 vector. Also tau 0 vector equal to d by dt m into r cross v vector. So m into under braces dr by dt cross v plus r cross dv by dt or m into v cross v plus r cross a or m into v cross v equal to 0 plus r cross a or tau vector to r cross f vector or r cross f vector. So it may also be defined as the vector product of position vector and the force acting on the body. In mathematically, tau 0 equal to rf sin theta, f into r sin theta, f into perpendicular distance with distance from O to F, point O to F, or tau 0 force unit arm length. Again, if r perpendicular to p vector, then tau equals to rf, r into f. In projection from tau vector r cross f vector, so xi plus yj plus zk cross fxi plus yj plus zk equals to ijk xy yz fx fy fz. For system of particles, tau 0 equals to r1 plus f1 plus r2 plus f2 plus rn cross fn, or sigma I equals to n ri cross fi. For rotation, ri perpendicular to ai and ai equal to r alpha ri, so sigma tau I equal to alpha into sigma I equals to nmi ri square, or sigma tau 0 equal to I alpha. Conservation of angular momentum. From the definition of moment of a force and torque, we know that sigma tau external equals to dl by dt. If tau external equal to 0, this implies dl by dt equal to 0, or this implies L equal to constant. That is sigma Li equals to sigma Lf. Initial angular momentum is equal to final angular momentum when external torque is 0. This is known as the conservation of angular momentum of any body or system. That is I1 omega 1 plus I2 omega 2 equals to I1 omega 1 dash plus I2 omega 2 dash for rotational motion. Angular impulse J vector. It is defined as the product of the external torque acting on any body system and the time during which it is acting. That is J vector equal to tau external into delta Q vector. In elementary form, J vector T1 to T2 tau external into dt. Also tau external dl by dt, so tau external dot dt equal to dl vector. This implies T1 to Tt tau external dot dt equal to Li to Lf dl, or J vector to Lf vector minus Li vector, or J vector equal to del L vector. Hence the angular impulse also be defined as the change in angular momentum, same like as linear impulse. That is change in linear momentum is linear impulse. Position of center of mass in angular frame. It is another form of conservation of angular momentum, and center of mass in angular form is given by theta cm equal to I1 theta 1 plus I2 theta 2 plus delta sin n theta n divided by I1 plus I2 plus delta sin n equals to theta. This plus theta cm equals sigma I equals to 1 to 1 II theta I divided by sigma I equals to 1 II. If the net external torque acting on any system or body remains 0, the angular position of the center of mass remains always constant. That is, if sigma tau external equal to 0, this implies theta cmi equal to theta cmf. An insect of mass m is initially at rest at edge of a disk m and radius r. The insect starts moving with the angular velocity omega naught or linear velocity v naught along the edge and covers the angular displacement theta naught. Find the angular velocity in angular displacement of the disk and the actual displacement of the insect. Solution is not given now.